Alright, so what we're looking at right now is how to do exponential growth with differential equations. So first thing that we need to know, so this is a differential. This is our main differential for exponential. So dy over dx equals ky. So if we solve this and we go backwards and we want our original equation, we would move the y's together and the x together. So now we can go ahead and take the integral of both sides. So if we integrate both of these, we end up with natural log of y equals k x, and then plus c. Right. So now we can solve for y. So we can do e to both sides. So we have e and ln would cancel. So we get y equals, we would have e to the kx plus c. And then we can split this up using our exponent rules. So we get e to the kx times e to the c. And then e to the c is just a constant. So we can take this c, and we're multiplying, or e to the c, and we can change it to just c. So we're going to multiply, so we'll have that out front. So we get c times e to the kx. So this is our equation that we need to be comfortable with. This is an exponential. So we need to be able to remember this. So we have our differential, which we need to remember, and the original. So we can go through this whole process, or you can just remember what it is. So if you run over a nail as the air leaks out of the tire, the rate of change of air pressure inside the tire is directly proportional to that pressure. So this directly proportional to something, this is going to tell you that this is an exponential problem. So write a differential equation that states that fact that the pressure is 35 pounds per square inch and decreasing at a rate of 0.28 pounds per minute. Okay, pounds per psi per minute. So at the time the nail is struck, so what we need, we have a rate of decreasing. So we have this fact. So this is our rate. So dy over dx is indeed a negative 0.28. Okay, so we know that. So if we were to write a differential equation, I have our k is unknown. So I'm plugging this into our slope, our change. And then we need pressure. So initial pressure is 35. So finding our k value, we would get k over, or k equals negative 0.28 divided by 35. So that is our k value. Okay, so now we can write a differential. We can say dy over dx equals, so calculating this out, actually let me get this, I think it's like negative 0.008 or something. So negative 0.28 divided by 35 is indeed negative 0.008 p. So there's our differential equation. Okay, so now we can solve the differential equation. So we know that the formula, when we went through that in the beginning, we have I would equal, the C value is always, like if we go back and we think about, if we plug in time 0 for the x, this would be e to the 0, so that would just be 1. So our initial value is always that C value. So our initial pounds per square inch is 35. And then we have e to the k, which we just calculated. That was the negative 0.008. And then we can say x or t. Doesn't matter. I mean, time, I guess we could write a t. That's right. So that, we solved the differential. Okay, so now, what will the pressure be 10 minutes after the tire is punctured? So what we're doing is plugging in 10 for time. So 35 e to the negative 0.008 times 10. That would equal our output. So calculate that, and that would be how much pressure is in the tire after 10 minutes. So we have, let's see, 35 and times E. We would have 32.309 pounds per square inch after 10 minutes. Okay, so I'm actually going to cut this video and do another video on another example.